Hello everyone, and welcome to our webinar about adopting digital twin to drive innovation. My name is Martin Saldert, and I'm going to be hosting this event today. I'm working with Symetri in Sweden, and together with Guido, we're going to introduce you a little bit more of what you can do with the digital twin. But for the new people here, first let me introduce Symetri a little bit. Symetri is a Swedish company that over the years have grown to almost cover most part of the globe, at least, well, depending on how you count it, but we're pretty big now. We're about 800 employees. We have about 250,000 users daily of the licenses that we sell. And we have 30 offices around the globe. So we are pretty big. And I think we're more or less the world's biggest Autodesk reseller at the moment. So, and our goal for you is to help you to work smarter for a better future. And this has to do with both money and time, but also sustainability. So we can help you and challenge you to work better. And one of the things that we want to do this with is the digital twin, because with the digital twin, you can test a lot of things before you actually start building them. And that will save you a lot of time and money, but also resources, and you can optimize your machinery and your stuff before you start building them. But before we start, there's a little bit of housekeeping. We have a Q&A window where you can type in your questions for me or Guido or for us, and then after the webinar is done, we will go through them. Depending on how much time we have, we might not cover all the questions, but then we will answer separately in emails. So without anything else, I'm leaving the stage to Guido so he can keep talking about the digital twin stuff.
Thank you, Martin. And I believe we first have one poll question to the audience, in which we will have several poll questions during the entire session. So this is the first question on your business digitalization transformation strategy. You can select one of the following. So how are you working with it now? Is it a process transformation? Is it a business model transformation, domain transformation, and cultural and organizational digital transformation? Please submit what at the moment is the strategy at your company or what you're looking at. And we will also quickly dive into the results when we have most results in, so that everybody also in the probably also interesting for you as an audience to know from others in industry what and how they are tackling this digitalization transformation. And of course, also keeping in mind the role of a digital twin in this full process. If you already see things happening on that horizon at your companies. So do we have the results? But I see a process transformation as the biggest amount of votes. So without further ado, let's go into the presentation itself. I will first give you a short introduction video also on us as a company and also on our solution.
In an ever-advancing world, manufacturing companies are looking for new ways to work in greater alignment, more efficiently, and more safely. That's why we built Prespective, the world's fastest growing 3D simulation software for the industry. Prespective enables users to build a digital twin of their machine that behaves exactly like the real machine will when it's built. Customers can do this with their own team of experts or let our team of experts do the work for them. Due to our extensive partnership with Unity 3D, Prespective has users all over the globe, from the US to Korea, and from Australia to Amsterdam. Come and see why companies like Philips, Toyota, and Festo work with real-time 3D simulation software. And come and see the future in Prespective.
So yeah, again, thank you, Martin, and also thank you, Symetri, for this time to introduce our vision on digital twins and also on our solution in that realm. So our company is called Prespective. We are a Symetri partner, so we can work closely together on the topic of digital twins with a focus in industry and infrastructural setups. So first a bit about me. I'm one of the founders of this company. This company is started from the Eindhoven region in Western Europe, so the birthplace of Philips, and nowadays also known from ASML, the chip manufacturer, which is around the corner, and it's also one of our clients. We have started this journey about 17 years ago, and 7 years ago, we really focused on digitalization and digital twins for industry. And you already heard in the video, and some of you might not know, or some of you might know, Unity 3D. Unity 3D is a real-time 3D engine, or in short, a gaming engine. And we more or less, together with them, made it suitable for use in industry. So we closely also work together with Unity on the global stage to bring in what I will explain later on, real-time 3D technology to the industry, to use it to build digital twins in different kind of use cases. And that's of course something we will touch base on during this presentation, what we think are at the moment valid use cases, which can directly also give you quick buck for your money, and also how this will expand in the future. So on a need level, we of course see that we all want to go to a more sustainable world, and the technology that we'll be talking about today can help also to do this, and also enable, of course, the technologies. So that can be solar, wind, to even also make the world more sustainable. We do this via the use of the virtualization that is nowadays possible. And with that, we mean, in the past, of course, you could do a lot of, after something happened, something went wrong in a machine or a system, you could look, or a factory shop floor, you could look what happened, and you can act on that. And of course, in the last years, everybody wants to do more inspection during acts, wants to react on what's happening. But due to, of course, simulation technology and extension of that now into real-time 3D, you can plan ahead. So to do this, of course, you need to build a rich virtual model, and that rich virtual model can be dubbed a digital twin. And that brings us to what we more or less see as a not full definition, because it's still in flux, but as a common definition for digital twins. So what we mean with it is that you try to build a virtual representation of a system as close in the digital realm as possible, of course, given constraints also of money, time, and effort, to solve use cases with a virtual model, which are going further than what most of you might already be doing in 3D and stuff like that. And that gives me directly the poll question number 2 for you to answer, to look how you see that and how you are looking into this realm. So what is your industry focus within your organization? Also to know, of course, from each other who are in this kind of call setup, what are you working on, and how can, for example, so then later the digital twin be beneficial for you? And you can see the ones: engineering, manufacturing and operations, maintenance and facilities, and architectural and construction. So then we probably also get the answer. So most are in engineering, manufacturing and operations. Interesting, because those are the 2 main topics we probably will be focusing on today within this presentation, and also within the use cases of a digital twin. And so as said already, here you can see that we focus on the virtualization. So really building a full virtual model of a system. And of course, most people then ask, so yeah, what's then the benefit and how does this differ from the past? That are 2 separate questions. So the main benefit, of course, is also dubbed by the inventor of the word digital twin, Michael W. Greaves from the United States. In the 70s and 80s, also when CAT came up, he already was working on simulation on the next steps, also within the NASA projects. And for them, the main benefit is, of course, inefficiencies that we still have in projects. Those inefficiencies are on 2 levels. It's, of course, us with our colleagues. So it's hard to articulate what we mean, and even also to understand what another person means. And of course, visualization in 3D already gave us a lot. But the next steps are to also visualize it in motion and simulate as much as possible, so that before we build something, or before we are going to order parts, before we are going to set up a shop floor, we already know quite a lot of the setup, and also within the stakeholder conversations. So it leads to more efficient information development over a process. And then, of course, a lot of people can say, rightly, how does this then differ from what's already happening in the past, looking into simulation software? In that sense, it's just an evolution and not a revolution. So one thing is, of course, the fact that software needs to be more open nowadays, so that you can connect multiple data sources together. But the other thing is also a bit of a technical revolution, is the fact that we nowadays can have real-time 3D engines. And why is that important? That has to do with that visualization part, so that you can visualize a rich working model or even see the operation of your shop floor as it is happening. And also the fact that you can do more simulation on that. And you can test, for example, also the logic of the system versus that virtual model. And that was something that was hard in the past, sometimes even impossible, which the last 5 to 10 years has become possible due to the fact of the use of real-time 3D engines, which on themselves are also trying to be open, so that you can push in quite large contexts. Looking at companies, of course, most have different kind of setups from hardware to software, and those can now be combined. And in the past, that was only done in, let's say, separate siloed software offerings. Those can now be hooked in together to bring you such a rich model. More on that in a later slide. A little bit then on Unity 3D. If you look at the space of the real-time 3D engines, there are probably 3 or 4 major players in the world. One of them is Unity 3D, which we see that a lot of the clients we offer already have quite a lot of licenses on, for example. So they are really training people in this next evolution in, let's say, 3D plus simulation plus logic. So a little clip on how you can utilize that on Unity 3D. I will also open the video for that one. There we go. So yeah, what drives this all? Of course, the exponential growth of technology is still going on. So one thing to understand is, of course, the fact that CAD software on itself is nothing new. Normal simulation software is nothing new, but the fact that we can now utilize also graphical processing units and, of course, have bigger PCs, but also more capable software, gives us the ability also as smaller companies or bigger companies, but also with different kind of budgets, to really use the technology that NASA had in the past to look at, let's say, a simulation of a voyage to the moon, for example, but in the case of an industry, of course, of how to build a system or how to build a machine or to look at a line or to look at a factory shop floor or a plant. Is it beneficial? Can it work as suspected? And in that sense, it has, of course, a very rich history. So it's more still on adoption and some technical changes the last 10 years that now make it possible for larger audiences, more companies to use this. The difficult thing, of course, is when you're looking at Industry 4.0 and the digital transformation, that me, but also others, of course, always like to talk about 0.6, full adaptability, which is like your self-driving car, but then on a shop floor level or a machine level. But of course, the honest answer is that's a journey for every company and for every engineering department to get closer to that in that journey and closer to that end goal. So of course it starts with connectivity, starts with more data, starts then with visibility and transparency on that level. But with this kind of real-time 3D technology, you can already quickly get benefits from that and then work towards, let's say, in years, in steps, to also connecting in the things that are now popular, like artificial intelligence and machine learning. But good to understand, of course, to get there, you first need to build a model, so a virtual model in which you can look, for example, for that adaptability. And now these are the tools so that you can build up that model, which comprises out of CAD data, IoT data, or logic, and already flip a switch and look how that will work. And then later, in steps ahead, look at prediction and adaptability. What's really also important in our opinion and to understand is that it's not only a simulation tool or a digital twin tool for the twin itself, but also for the communication between the disciplines. In industry, of course, we more or less have built silos because of efficiency. So we have mechanical engineering, we've got mechatronical or electronical engineering, and we've got software engineering. These are now also tools to bring the disciplines together and to give them, let's say, a showpiece on which they can have opinions on and get consensus on, because it tries to bind the disciplines together. It tries to bring a virtual model in which stakeholders can have their say, and also to go over the Tower of Babel problem of the jargon that everybody speaks. You can actually see a machine and have a discussion on a valve, and then one calls it a valve and the other calls it a motor and a switch, and you can still have the discussion on the same level with people. And that brings us to poll question number 3. So also looking into, of course, a twin comprises out of data. So the question is also looking at the maturity level, of course, what kind of data does your organization consume? So we will get the results. So interesting, most already have CAD models available, which of course is hopefully not a surprise, but we still find a lot of companies that do not have them fully. And they can be more or less the material that you can use for your to set up a digital twin on the 3D CAD system. And then going into, so what is the value of this kind of twin setups, of these virtual models? And I will also elaborate a bit more why it's important to start probably at this kind of proto level and also on this engineering level with a digital twin. But one in the engineering process is the fact that nowadays most companies still work in a very linear process, which in itself is not weird, because of course the origin of machines and factories came from engineering and mechanical engineering, and later the other disciplines like electronics and also software came in, and it's still mostly a linear process. So what this kind of technologies bring, so that you do more simulation, more, let's say, combined virtual modeling, is that you have a system development which is more in parallel. Disciplines can work in parallel together, and you can, of course, understand the virtual model can be shared, so more people can work on the same virtual prototype or virtual products. And you can have also more conversations, and also with outsiders. So not the ones in the R&D team, but also not even the ones that do deployment, but even the client can see, okay, you are promising me a machine or a setup. I can already flip a switch virtually and see that happening. That gives me more confidence that what you're promising me will be valid and will work. An interesting, one of our biggest clients here in the Netherlands is Philips. And I will show a use case in how they use this virtualization on multiple levels. And I will expand a bit more after the video clip. Here the video comes.
Within Philips, we embarked on the road to Innovation 2025, and that's a digital transformation. For integration and test, we aim for a higher quality. Higher quality you get by higher test coverage. You want to automate your tests and also make use of a flexible system-level test environment, and that's the virtual test platform.
In the Vivaldi project, we have created a virtual test platform which simulates our X-ray systems and which is also able to switch between different configurations. When we use our automatic test, which we were also using on a real X-ray system, we can run it on our virtual test platform and run those tests in one night with several configurations after each other. The main benefits for a virtual test platform instead of an expensive X-ray system is that you can run automatic tests continuously on a virtual system, including configuration switching without using a real system. And the main benefit of that is that you have continuously feedback and find early defects, early quality insight already during the development phase.
Yes, so we're back in the presentation. So also to elaborate a bit on what you have seen. So Philips used this over what you could call the entire R&D cycle. So they use it also in simulation or in visualization during the conception even of new machines, but they also use it in testing, so to have a higher test quality. And they also use it to even do, let's say, what you could call a factory acceptance test and a site acceptance test. Does it then get all the marks? Does it fill in all the questions? Of course not. So it's still a visualization and simulation, let's say a real representation of the actual system, but it gives them very close let's say, tests and assumptions on this system. And for them, which could also be valid for you, is the fact that they cannot, of course, it are expensive machines, but they cannot even have all the configurations of these machines, or let's say the design configurations that they would like to test, because there are 300 different kinds of ways to set up the system. And they want to test on all kind of levels, let's say software, but also interaction with a patient and interaction with a physician. They can now all test them virtually using this kind of setup. So this kind of technology. These are their own figures, because a lot of people also ask us and also Symetri, so what is the gain if you start to work with this? It's the hardest part is that it's probably still, let's say, contact related and company related, how it really is beneficial. So Philips for themselves made, of course, the business case and checked the business case. And the saving is now about 260k euros per machine that they deliver, due to the fact that it's more efficiently built, it's better tested, it has higher test quality, and they are quicker in uptime at site. And of course, later this twin can survive with its actual field partner, so that they can even collect this rich data on it and use this rich visualization to, for example, also look if there has been a mistake or an issue with the system. They can run that on the virtual counterpart to look what has happened. That brings me to the digital twin landscape. Digital twin itself is a broad term, and it's more or less, let's say, the next iteration on simulation and also big data. But what we have seen in the last 7 or 8 years is that the conception of a good digital twin most of the times happens at the engineering level, because there is, of course, the more purest data, the CAD data, for example, but also the understanding of the machine that is wanting to be built. And it's also the way in which you, as a company, can have greenfields, so that you can really fully test this kind of capabilities. And of course, once then the system goes into the field via, for example, virtual commissioning, then the digital twin can stay alive as a monitoring dashboard, but can also be used for training and other stuff. But that's also why today we focus on the, let's say, the hashtag, how do you do this? Is the fact that you start mostly with the rich data model, which is available in the engineering phase of a new system, a new plant, or a new facility. And that's then where this kind of technology can come in to already get that digital twin in infancy, that then becomes later on mature, also when the actual system goes live, for example, and stays live. So if we talk about virtual commissioning, you can see some examples here. And I will I cannot skip this one. But here you see actually what we mean on, let's say, low level, on OT level, but it also goes to IT level. The left one and the right one, so this is a Festo machine versus the digital twin. This is not an animation, they are running in parallel. So the software that runs one also runs the other. You can use this to test software, but you can also use it to visualize the state of a system as is. And then you get, of course, rich insights. And in this case, for example, this is also being used by students during COVID to train themselves on the programming of these Festo machines. So that gives also the glimpse on how this is being used and the capabilities also in prototyping and commissioning. And a good example of such a case is this. One of our biggest clients is also Toyota Material Handling and Toyota Motor Company. And of course, Toyota is one of the inventors of Agile and Lean. They more or less want to look at mechatronics and systems also as a lean process. Of course, a process that's already familiar in software. They want to address that also in building new systems. So what we then more or less give them, or what they gave them themselves, is the capability to create virtual steel. And with virtual steel, you can do a lot of iterations, you can do a lot of testing, and they have a cycle of 2 or 4 weeks in which a team can build a new setup of a machine, and they can have all kinds of tests on them, all kind of assumption testing. And of course, this can then later be live as well. And here you see the thing is also you can pick and choose where you connect it. You can connect it on a model, you can connect it on software, or you can connect it on hardware in the loop, which we call mill, SIL, or HIL. And that's the openness and the interoperability that let's say the open real-time 3D engines like Unity offer you, and what Prespective and Symetri can offer you is also the tools so that you can alter and build this model, because otherwise it would be still quite cumbersome to do this. And we have also seen that it's of course also involving some theory. So also for your understanding, this is probably on the level that CAD was in the 90s. So what we have seen is that our experience as teams, we also try to transfer by doing MVPs and POCs with the clients to the clients, because we are not in the game of having this theory with ourselves, but we have seen that it can be daunting if you not fully understand how you can connect things. Of course, everybody in the call is probably very capable, but it's just experience that has been built up in the last 7-8 years on using digital twins in industry. So that can be on machines, it can be on lines, it can be on plants. This, for example, is a cell, and in this cell you see that the HMI in this part resides on the table, which is feeding into a logic controller, which is somewhere else, which goes into the simulation, and then you can test stuff. But this is, of course, also a way to visualize the state of the actual cell once it's in the field in a rich virtual way, and that can help also to do more finding of defects, because sometimes defects are not only in, for example, the code, of course, they are in the full, let's say, setup of a system, and that setup plays out in 3D and time. And that's what this kind of capability brings you, the 3D digital twin technology. And then, of course, people can ask, so, okay, interesting, but how then? So one thing is, of course, most of you answered, there is CAD data available. So that CAD data is part of the puzzle to build this virtual model. You want to also build in, let's say, emulated sensors and actuators, or you want to give a way to give information to this virtual model over a logic line. So that can also be a SCADA, a MES line, but also OT, so a PLC. And then you can start visualizing flows of product and material and even people, so that you can really see a rich model. Or you propagate the state as is of the plant and show people what's actually happening at the facility using, for example, the MES and SCADA layer. So here you see, let's say, a dummy setup and how that is then also partly built in tooling. So this is how this kind of digital twin tooling looks like. It's really the hybrid and marriage between 3D, let's say, sensors, actuators, mechanical, mechatronics, and software. And then you can more or less flip a switch somewhere and look how this will all play out. And as you also saw in the, let's say, the full digital twin line, this can also be used in sales engineering, but this can also be used in configure to order. But again, you first have to, of course, know what you are going to configure. So it's good to have a virtual model, which you can then later use in sales engineering, or let's say in configure to order setups. So maybe also back to why did we do what we do? Here in the Netherlands, we saw, and also with other large companies, that they were stuck within the existing solutions, which were more, let's say, software silos as well. So they wanted to have a kind of an open platform. So let's say an operating system for digital twins. And then in this case, an operating system for digital twins in real-time 3D. So together with them here, we found that Unity or a game engine is really capable to do this. But the only thing they also, of course, miss is authoring tools. So tools to then build up that virtual model, because Unity gives you a sandbox. So that's more or less, you have Windows. Then you probably still need Excel to do, let's say, good worksheets on them. And that's what we bring. So the tools that you can put in the CAD data connected to, for example, physics or software. And if you don't need physics, to at least visualize and, let's say, animate and transport, let's say, flow of material and products, so that you can really have a good representation or a simulation of the system that you're going to build. And you can then output it, as you have seen also in the clip of Unity, also to the, let's say, old or new tech of virtual reality and augmented reality, due to the fact that Unity is one of the biggest SDKs that all the vendors of hardware and software for AR and VR and MR deliver directly gives you, like the HoloLens and the Magic Leap. So you don't get that fully for free, but almost for free. If you build a virtual model in Prespective Unity, you can push it there. And as seen, we are more in this case like Switzerland, so you can connect multiple brands of data sources from CAD to IoT, but also of hardware, to build up your own, let's say, blanket of this virtual model, because that's what we have seen. Of course, most companies have different kind of, also from vendors, different kind of formats and import files. They can now here be connected to each other. So also to show, of course, it can also be on a line level. And then once you, of course, have your models on a line level, you can also play with them. And then you get more ready to the adaptability, and it brings you to sales engineering, it brings you to configure to order. And then your blocks can really be reused. But you first, of course, have to build that virtual model block so that you can use this on a larger scale as well. And some examples also of configure switching on a shop floor level. So here you see such a tool of one of our clients. They want to look at a small shop floor setup and they want to experiment a bit with different kind of configurations. They have built themselves a library of those so that they also partly first with our help, later with their own help, so that they can look at this. So here you see, of course, the fact that it's real-time 3D. So it's not only CAD, it's also behavior, it's material transport, there's robotics involved. They are all more or less brought in to this virtual model so that people can use this for this kind of use cases. So for them, this is kind of configuring the line for a client, for example, and looking if they can make the KPI on that line. And it's really the fact that they can bring in their own CAD models, their own logic, because that's sometimes we see with, of course, other vendors, they can have a kind of similar offering, but we really focus on the fact that you can bring in your own mechatronical concepts so that you can bring the full constellation to your clients on that side. And here, for example, we have that on the machine level. So that was on a line level, but this is more on the machine level. This is a fully configurable, let's say, virtual model, which includes the material flows on them. And they, for different kind of client, can say, okay, I want more carton in, I want a larger carton, I want to have it wider, smaller. But of course, to get here, you have to offload a lot of information first. And that's why also in this presentation, we honed in mainly on building this virtual model first, because then you can reap the benefits of also using it in sales engineering or hooking it into a dashboard, for example. We have also, of course, built a lot of those, but we have seen that we always have to run to engineering and together with engineering to build up the virtual models that make that possible. And the digital twin technology makes it possible, but then of course you also have to connect the data sources to get to this kind of level, and you see the changes. As said in the beginning, we don't only work for industry, but also infrastructural usages, of course, can be very interesting. You can understand, because also these are very expensive, let's say, artifacts, bridges, tunnels, in our case, in the Netherlands, also dikes. And for example, in our case, our own government made it mandatory to build a digital twin of every asset they have to maintain. On all the levels I presented in the use cases. So this is for in the building phase, so that everybody agrees on the, let's say, the scenarios that the system has to work on. It's to test the software. It's also to train the bridge operators. It's to look at scenarios. So what if the hospital car comes in? And this is also hopefully opening your mind on the usage that you can also, of course, foresee in industry. And the interesting thing, of course, with a bridge or a tunnel is you try to be first time right, which of course in itself is hard, maybe impossible, but this kind of technology makes it possible to get as close to first time right as probably humanly possible at the moment. But then going back, of course, the aim is to go to level 6. So in our case, we also worked, which is now the other company for Philips, is Signify, to build a fully autonomous plant setup. And then you'll more or less try to build the self-driving car for industry, so off your shop floor or off your machine line. And then it becomes really important, of course, that you do as much as you can do virtually. And that's also what Tesla and Waymo do with self-driving cars. The most kilometers of these cars are driven virtually, because of course running, in this case, an AMR, so an autonomous mobile robot, into an actual wall is more expensive than running it into a virtual wall. And that's hopefully also explaining as an end on why this is a kind of important key enabling technology if you look into the future. So the combination of 3D, motion, software, behavior, and also, of course, data that can be combined to build this kind of setups and to build the factories of the future, more or less, and the machines of the future. So that brings us to the final poll question of today. So now that you are more aware of what we can offer, what areas of your business do you feel digital twin could be have an impact on? So select one of the following, which is visualization, collaboration, simulation, or process optimization. And of course, you can also use that as a dashboarding tool. But as said, then you if you want to do this on the real digital twin level, you probably also need the data from R&D. So some time to answer the question on your end. Yes, then we get the results. So simulation and process optimization are the ones that are highest in favor. So on our end, this is more or less the conclusion of this webinar presentation part. And I will now hand over back to, I believe, Martin and Emma to also guide the Q&A.
Hi, yeah, we just got a couple of questions in, Martin or Guido. So first one, how do you see the future of digital twins in manufacturing?
Yeah, so what we see happening now is that, of course, this adoption is, some people, of course, seeing all the buzz, think it's already high adoption, but it's still it's starting. And of course, that's also why we brought in the examples of, for example, Philips, and we have more of this kind of clients that reap the benefits already of this technology. The other thing is, of course, we are working towards standards. So it, of course, combines multiple data sources. So in the works, together with others in the industry and in Europe, there are coming some standards online so that you can even also make, once you have built a virtual model, them exchangeable. And that also means the connection between the major platforms and the major players. I think now in the digital twin space are Unity with us, Siemens, Unreal, and of course also Dassault and Autodesk. And you see that now also with NVIDIA are coming interchange formats for that. So that's also a step in the next few years that the industry is taking. But the thing is that you can quite quickly already gain the values now. So combining a CAD file, making it interactive is not that hard. If you do the first time, it can be a bit daunting, and that's why we, together with Symetri, hope to help first. And not because we don't think that you cannot do it, but that's our experience. So that's probably part of the answer.
Okay, another one. How does a digital twin support the development and testing of new products or processes?
Yes, so in the case of Toyota, you can have seen a quite compelling case. So what it does, it tries to help, of course, to, let's say, put things in parallel. That makes things also from a lead time perspective shorter. So teams from the various disciplines can already start working together. That can be even a rough, let's say, 3D plus time sketch, so rough boxes. But then also software engineers, for example, can already have a glimpse of the concept of this new machine or system. And the same, of course, goes into 3D engineering, so that people can already visualize and push also the motion into this 3D, not as an animation, but as something that's interactive. So that in discussions, let's say stakeholder and design discussions, you can have a valid discussion on that. And some simple things, for example, is that we also have annotation tools within 3D plus time. So that if you have a machine in this virtual object, you can flip the switch and you can even say at 20 seconds, I can see something go wrong. And then the floor with four or five people can have a discussion on that and write even notes directly in this virtual setup. So there it really helps in communication, aligning people, and already testing assumptions early on, and also on an iterative level. So in sprints of 2 to 4 weeks, but also more people can have a virtual model. Every tester that wants to test something can have its own virtual prototype in that sense.
Okay, thank you. I've got another one. I work in medtech and pharmaceutical, which are regulated. We are planning to look at moving forward from virtual commission to virtual validation. Do you have any comments on virtual validation?
Yes, so in the case you saw with Philips, we are together with Philips working also on the FDA approval so that they can even do site acceptance testing on the FDA level. So this kind of validation and testing together with regulatory bodies is probably something that's also possible in the pharmaceutical domain. Of course, depending also on the qualities of the virtual models that are used for it. And also always be aware, of course, of the fact that there are some blind spots in the virtual model. And that's, of course, also something that then has to be taken into account. And that are also things that we're together with Symetri, we are experienced on to look together with the clients, so depending on the use case of this twin, on how to implement that. And that's exactly what you saw in the Philips case, for example.
Thank you. And another one, what are the possibilities for simulating fluid dynamics?
Yeah, so what you see there, what the possibility is, fluid dynamics is still rather difficult to do that real-time 3D. So there are 3 ways to approach that. One is to hook in, let's say, other linear software, so which renders out the simulation, and hook that into Unity and Prespective. What you can also do is, if you have a good solver for it, try to render that in Prespective and Unity directly. And another way is there are at the moment coming quite capable, let's say, physics engines online, which can help in this kind of more difficult setups within the Unity ecosystem. But there are different kind of variants and different offerings for that. So what we also do together with Symetri is we can look at the actual use case which you want to have this fluid dynamics for, and how to integrate those. So that can be on one of the 3 levels I just presented. So that is how you can tie in fluid dynamics, but that's of course the more difficult one. Another one is that we also have kind of, let's say, solvers, discrete event simulation solvers, which can have an approximation on fluid dynamics. Hopefully that's the partly answer, at least for now. So that's something for let's say further discussion. Such a deep question.
Okay, thank you. I think that's all the questions for now then, Guido and Martin. Thank you.
So then we'll say thank you for today, and thank you for listening, and thank you to Guido for doing this presentation for us. And if you have any other questions or whatever, you can always contact us at Symetri, and we will help you with whatever you need help with. So thank you very much for today, and see you next time.
Thank you all for listening, and thank you for your time.